motion of a charged particle in a uniform electric field. Motion of a charged particle in a uniform electric field. So this is a positive charge, that is plus q charge, which is at the point A. At O, we have a positive charge, that is plus q charge, and which is moving with a velocity v, in this direction with a velocity v. And this charged particle is trying to enter. That means the charged particle travels with a velocity v along the direction OX, and an electric field acts in this direction, a uniform electric field E acts in this direction. That means the positive charge plus q enters in a uniform electric field with a velocity v in a direction perpendicular to the electric field. This is a positive charge, and this positive charge experiences an electrostatic repulsive force Fe in the direction of electric field E. Fe is the electrostatic force, and if we consider the resultant motion of this positive charge under the combined action of this electrostatic force Fe and kinetic inertia of the charged particle along x, the charged particle will travel. The resultant motion of the charged particle will be along this direction, denoted by violet color. That means the resultant motion of the charged particle will occur along this curved path in this uniform electric field. And beyond this electric field, the charged particle will describe a straight line trajectory. This will be the straight line beyond the uniform electric field. And this is the screen on which the charged particle will strike. A is the point after which it will be outside the electric field. AC is the straight line path described by the charged particle beyond the electric field. And here a negative plate is placed towards which uniform electric field E acts, and a positive plate will be placed at this position so that electric field E acts from positive plate to negative plate. This is the positive plate and this is the negative plate. Electric field E acts from positive plate to negative plate because electric field is the force experienced by unit positive charge. In this direction, electric field will act on this positively charged particle, and we can extend the screen. We can denote the direction of electric field at other point between the two plates. This is the direction of electric field, another direction of electric field. So in this way, uniform electric field acts between positive plate and negative plate. And A is a point up to which the charged particle reaches in the uniform electric field. This will be the direction of uniform electric field which acts from positive plate to negative plate. The charged particle, these are the direction of electric field. E is the electric field intensity of this uniform electric field. This point will be the G. So this displacement of the charged particle in the direction of electric field is Y. When the charged particle reaches to the point A from O, displacement of the charged particle in the direction of electric field will be Y, and the displacement of the charged particle in the direction of OX will be X. At the point O, time t is equal to 0. At the point A, time t is equal to t second. That means after time t, the charged particle will reaches to the point A from the point O. This path is parabolic path within the uniform electric field. This path is the parabolic trajectory or parabolic path described by the positively charged particle moving in a uniform electric field, and it tries to enter perpendicular to the direction of electric field. Beyond the electric field means beyond the point A, the charged particle travels along the straight line AC. Let a charged particle of charge plus Q and mass M, charged particle of charge plus Q and mass M traveling with a velocity v, along OX, along the direction OX, be subjected in a uniform electric field, be subjected to a uniform electric field E, uniform electric field of electric field intensity E, which acts along OY, This point is O and that point is OY, which acts along, this is the point O, and electric field intensity acts along OY, which is perpendicular to OX. That means the charged particle enters in a uniform electric field such that the direction of motion of the charged particle is perpendicular to the direction of electric field. The electrostatic force experienced by the charged particle plus Q in the direction of uniform electric field E, in the direction of the uniform electric field E, along OY is Fe equal QE, product of charge and field intensity. And charged particle enters in this uniform electric field in a direction perpendicular to the direction of electric field intensity. Electrostatic force Fe equal to QE due to the combined action of due to the combined action of electrostatic force Fe in a direction OY and due to the electrostatic force due to the combined actions of the electrostatic force Fe along OY and initial kinetic inertia with a velocity v. Initial kinetic inertia, not inertial, kinetic inertia with a velocity v along OX. The charged particle plus q travels along the curved path OA in the uniform electric field. In the uniform electric field E. In the uniform electric field E. Between the two plates Y1 and Y2. Between the two plates Y1 and Y2. These are the two plates Y1 and Y2. Y1 is the negative plate and Y2 is the positively charged plate. Beyond this electric field, that means beyond the point A, the charged particle plus q will travel along a straight line AJ, along the straight line AJ. This is the screen on which the charged particle will strike. Therefore, the acceleration of the charged particle plus q in the electric field in the direction of the electric field E. The acceleration of the charged particle plus q in the direction of a uniform electric field E along OY is A equal Fe by m or A equal QE divided by m. A equal QE divided by m, that is the expression of the acceleration of the charged particle in the direction of electric field intensity. Plus q be the charge which is at the point O and which is trying to move with a velocity v along OX. And this charged particle is subjected in a uniform electric field which acts along OY such that the charged particle is trying to travel in a perpendicular direction with the direction of electric field intensity, and Fe is the electrostatic force experienced by the plus q charge due to electric field, and A is the acceleration of the charged particle due to the electrostatic force Fe, and V is the velocity with which the charged particle enters in the electric field, and due to the combined action of the electrostatic force Fe and kinetic inertia along OX, the charged particle describes parabolic path, and beyond the electric field the charged particle describes straight line path. X is the distance or displacement of the charged particles along OX when it reaches to the point A in time t, and Y be the displacement of the charged particle when it reaches to the point A. If the charged particle plus q charged particle plus q travels from O to A in time t, from O to A along the curved path OA in the uniform electric field E, in the uniform electric field of field intensity E, then the displacement of the charged particle, the displacement of the charged particle plus q in the direction of the electric field E, that is along OY, with the acceleration A is given by y equal v cos 90 degree plus v cos 90 degree dot t plus half a t square, using s equal ut plus half a t square. Using the equation s equal ut plus half a t square, where v is the velocity along OX, and if we consider the component of velocity along OY, then we should consider the rectangular component of velocity, that is v cos 90 degree. V cos 90 degree is 0, so finally we get y as equal half a t square. But we get the expression of acceleration A as q e by m bracket close into t square. Y equal half bracket open q e by m bracket close into t square, equation 1, which is the displacement of the charged particle in a direction of the uniform electric field E. Y equal 1 by 2 q e by m bracket closed into t square, where t is the time taken by the charged particle to complete the curved path OA. Again, the displacement of the charged particle along OX, the displacement of the charged particle along OX, that is in the direction, in the perpendicular direction of the electric field intensity, is given by x equal v dot t plus half a cos 90 degree into t square. Acceleration is along the direction of electric field intensity, that is along OY, and acceleration along OX will be a cos 90 degree. So, or x equal v dot t, therefore t equal x by v. That is equation 2. That is the time taken by the charged particle to travel from O to A, where x is the displacement of the charged particle along OX. We can draw the negative and positive plate, and plus q be the charge which was at the point O, and it is and the charged particle is trying to enter in the uniform electric field in a direction perpendicular to the direction of electric field intensity. Charged particle enters in the electric field in a direction OX. Resultant motion of the charged particle will be along the curved path, that is along OA. X is the displacement of the charged particle when it travels from O to A along OX in time t, and x is the displacement along OX, and y will be the displacement of the charged particle in a direction of electric field E. A will be the acceleration of the charged particle in the same direction of electric field intensity E. Putting the expression of t small t time, putting the expression of time t from equation 2 in equation 1, we get y equal 1 by 2 bracket open q e by m into t square. Y equal 1 by 2 bracket open q e by m bracket closed into t square, equal 1 by 2 q e by m bracket closed x by v whole square. Therefore, y equal 1 by 2 q e by m bracket closed, QE by mv square into x square, y equal 1 by 2 bracket open, QE by mv square bracket closed into x square. Therefore, y proportional x square. This is the equation. This is the equation of a parabola. Hence, the charged particle. Hence, a charged particle. Hence, a charged particle moves along a parabolic path. Moves along a parabolic path. Parabolic path in the uniform electric field. In the uniform electric field provided. In the uniform electric field provided, the charged particle enters in the electric field, enters in the electric field in a direction perpendicular to the direction of, in a direction perpendicular to the direction of uniform electric field, to the direction of uniform electric field. Additional information on leaving the uniform electric field. On leaving the uniform electric field, the charged particle moves along a straight line. Moves along a straight line tangent to the curved path or parabolic path. Curved parabolic path. That means the charged particle moves along a parabolic path in a uniform electric field. And if we return to the diagram, the charged particle will describe a straight line beyond the electric field along this tangent. The charged particle will be traveling along this tangent or along this straight line beyond the uniform electric field. So this is the straight line described by the charged particle beyond the electric field, and the charged particle describes parabolic path in the uniform electric field. Provided the charged particle is trying to enter the uniform electric field perpendicularly